Assalamu alaikum. My name is Ayila Naeem and here is my lab number 2 of DSP, and the title of my of this lab is Signal Representation. So starting from the task 1, which is entering the starting points and the limit. In line number 1, n0 is equals to -1. This line initiates the variable n0 to the value -1. N1 is equals to -3. This line initiates the variable n1 is equals to the value -3, and n2 initiates the value is equals to +3. In line number 4, this line creates a vector n containing integers from n1 to n2. In this case, n will be -3, -2, -1, 0, 1, 2, 3, forming an array. In line number 5, this line creates a binary signal x, where each element is 1 if the corresponding element of n is greater than or equal to n0 or 0. And in last, this command creates a stem plot where the values of x are plotted against the corresponding values of n. And here is the resulting output. Moving forward to the task 2, this line also initiates the value n0 is to the value of 1, n1 to the value -5, and n2 to the value 5. And this line creates a vector n containing integers from n1 to n2. In this case, n will be -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. And x is equals to n minus n0 is equals to 0. This line creates a binary signal x, where each element is 1 if the corresponding element of n is equals to n0 and 0. And at the last, this line creates a stem plot where the values of x are plotted against the corresponding values of m. And the resulting output is this. In the task 3, same as task 1 and 2, this line initiates the variable n1 is equals to -3, and n2 initiates the variable n2 is equals to 3. And this line creates a vector n containing the integer n1 n2. And in line number 5, this line calculates the value of the origin x for each value of n using the formula x is equals to 3 cross 0.5 raised to power n. This is an exponential decay for which each subsequent value of x decreases by a factor of half compared to the previous one. At the last, this command creates a steam plot where the value of x are plotted against the corresponding value of n. And the resulting output of both the codes are this, forming the discrete signals. Task 4 is the function impulse sequence. Create a function impulse sequence that is equals to unit impulse sequence and values. The unit impulse sequence generate a unit impulse sequence. Unit impulse sequence is equals to unit impulse sequence generates a unit impulse. The sequence of n specified by n values. Now moving through the code. Here n values is equals to -5 ratio 5. This line defines a range of indices and values from -5 to 5 with an argument n value. In line number 2, this line calls a function unit impulse function with an argument n value. In line number 3, this command creates a steam plot where the values of the sequences are plotted against the corresponding values of n values. In line number 4, this line sets the label for the x-axis, and this line sets the value labels for the y-axis and give them a title. And the resulting output of unit impulse sequence is this. In task number 5, again make a function unit step. Unit step sequence n values. Unit step sequence creates a unit step sequence, and the resulting code is this. Again, this line creates a range of indices and values from -5 to 5. These indices represent the discrete time points at which the step sequence will be evaluated. Generate the unit step sequence. This line, this is a commanding indicating the purpose of the subsequent code. Now plot the values, plot and stem the n values and the step sequences. And this is X label, Y label, and give them a title, and the resulting output is unit step sequence is this. In task 6, create a function named as flipped signal, and the code is this is a signal which contains the value 1, 2, 3, 4, and 5, which represents the original signal that will be flipped. And the flipped signal is equals to flipped signal. This this line calls a flip signal with the argument signal. This function flips the order of element in the input array signal and returns the result, which is assigned to the variable flipped signal. Display the original signal and flip signal. This display commands displays the string original signal, display the flip signal, and the resulting output is this. This is the original signal, and we flip the signal, and the signal will be flipped in the reverse direction, like 5, 4, 3, 2, and 1. In task number 7, create a function scaled signal index scaling scales of the index of the given signal. This line defines an array signal containing the value of 1, 2, 3, 4, and 5, represents the original signal that will be scaled. This line defines the variable scale factor that assigns it a value of 2. This represents the factor by which the signal will be scaled. Scaled signal is equals to index signal scale factor. This line calls the function index signaling with the argument signal and scale factor. This function performs index scaling on the input signal, which involves scratching and compression the signal along the time axis by the specified vector. The result is assigned to the variable scaled signal. And this display commands the string original signal, and the resulting output is this. In task number 8, make a function's shifted signal, and the code is this line defines an array signal containing the vector 1, 2, 3, 4, and 5. This represents the original signal that will be shifted. This is a command indicating the purpose of the subsequent code. And this line defines a variable shifted signal and assign it a value to 2. This represents the amount by which the signal will be shifted. The shifted signal, this line calls a function shifted signal with an argument signal. This function performs signal shifting on the input signal, which involves shifting all elements of the signal to the right of the specified amount. And the resulting output is this. In task number 9, which is the zero order hold simulates, create a function T zero order hold and X zero order hold. In this code, this defines the continuous time signal. T continuous is equals to T continuous creates a time vector T continuous ranging from 0 to 1 with a step size of 0.1. This vector represents the time axis for continuous time signal. And X continuous, this line calculates the value of the continuous time signal X continuous using the sine function applied to each point in T continuous. This represents the original continuous time signal. Define the sampling interval. This line T of S is equals to 0.5. This line defines the sampling interval Ts as 0.5. This value represents the sampling period for zero order hold operation. Stimulate zero order hold. Zero order hold T continuous and X continuous. This line calls a function zero order hold with the arguments T continuous, X continuous, and Ts. This function simulates the zero order hold operation. On the continuous time signal, this returns the time vector T ZOH and the sample signal X ZOH. Plot the continuous time signal and its zero order hold. This command creates a new figure window for the plot. Plot T continuous, X continuous, B T ZOH, X ZOH, and R naught. This line means this commands plot the original continuous time signal versus with the blue solid line and the zero order hold version with red circles. Label the time axis. This line sets the label for the x-axis as the plot as time and label the y-axis as amplitude, and the resulting output is this. And the last task is task number 10. Here the code is create a function tFOH and xFOH. In this code, T continuous creates a time vector T continuous ranging from 0 to 10 with a step size of 0.1. This vector represents the time axis for the continuous time signal, and x continuous is equals to sine T continuous. Uh, this line calculates the value of the continuous time signal x continuous using the sine function applied to each time point in T continuous. This line represents the original continuous time signal. Define the time sampling Ts is equals to 0.5. Stimulate the first order hold. Now plot the T continuous, X continuous, B minor, TFOH, XFOH, and R naught. Label the time axis as x-axis and amplitude as y-axis. Give them a title and add a legend continuous signal and first order hold. And the output is a sinusoidal waveform. Thank you for watching my video.